Cubes and dice, a topic of reasoning ability. There are wide variety of questions involved in this topic. For example, cutting a cube into number of pieces or coloring a cube and then cutting it into number of pieces. And also there are some questions related to non-verbal reasoning. In this video, I will take you to all such variety of questions. So let's move with the type 1 category. Cuts and pieces. So cube is a three-dimensional body having three directions, so-called X, Y and Z. Talking about the number of faces, number of edges and number of corners, there are 6 faces, 12 edges in a cube and there are 8 corners. So let's take a cube here. I make one cut parallel to X direction like this. With this one single cut, the cube will be divided into 2 pieces. If I make one more cut parallel to same direction like this, the cube will be divided into 3 pieces. If I make one more cut parallel to the same direction, now the cube will be divided into 4 pieces. So 1 cut, 2 pieces, 2 cut, 3 pieces, 3 cut, 4 pieces. If this is so, then what is the relation between number of pieces and number of cuts? Obviously, number of pieces is equal to number of cuts plus 1. Let's take some another cube. This time also I make one cut parallel to X direction like this. Second cut I do parallel to Y direction like this. And third cut I do parallel to Z direction like this. So here also I have done 3 cuts. But the cube will be divided into 8 pieces. So with the same 3 cuts, the cube can be divided into 8 pieces also, depending upon how we are cutting it. So what is the relation between number of pieces and number of cuts now? Number of pieces is equal to number of cuts plus 1 in X direction plus number of cuts in Y direction plus 1 plus number of cuts in Z direction plus 1. So I have made one cut parallel to X direction, one cut parallel to Y direction and one cut parallel to Z direction. Hence number of pieces will be equal to 8. Last time or in the previous example, we have done all the 3 cuts parallel to X direction and 0 cut parallel to Y and 0 cut parallel to Z. Hence the number of pieces obtained was 4. So 3 कट से 4 पीसेस भी मिल सकते हैं और 3 कट से 8 पीसेस भी मिल सकते हैं, depending on how we are cutting it. From this we can conclude that number of pieces obtained will be minimum if all the cuts are made parallel to one single direction, and number of cuts obtained will be maximum if we split those cuts equally among 3 different directions. So in this formula of pieces equal to Cx plus 1 into Cy plus 1 into Cz plus 1, Cx stand for number of cuts made parallel to X direction, Cy stand for number of cuts made parallel to Y direction and Cz stand for number of cuts made parallel to Z direction. Let us try out some examples on this. Problem 1. In how many pieces a cube will be divided if 3 cuts are made in one direction, 5 cuts are made in second direction and 6 cuts are made in third direction? So they have very well mentioned here what is Cx, Cy and Cz. So we can calculate the number of pieces. So I will substitute, suppose Cx as 3, Cy as 5 and Cz as 6. The number of pieces obtained will be 168. Option B is the right answer. Problem number 2. A cube is cut parallel to one face by making 8 cuts. What is the maximum number of identical pieces that can be obtained by now making 2 more cuts in any direction? Okay, let us assume that Cx is given as 8. Now you have further 2 more cuts to do. It's obvious that these 2 cuts, if splitted in 2 different directions, the number of pieces obtained will be maximum. So number of pieces is equal to Cx I substitute as 8, Cy1 and Cz1. The remaining 2 cuts I will split, one in Y direction and second in Z direction. Hence the number of pieces obtained will be 36. Question 3. What is the maximum number of identical pieces a cube can be cut into by 10 cuts? Now here in this case, we cannot divide 10 cuts equally among 3 directions, as 10 is not divisible by 3 to get maximum number of pieces. But can we split the number 10 into 3 parts which are as close as possible? Yes, that we can do. So 10 cuts को हम ऐसे split करते हैं. Let us say 3 cuts in X direction, 3 cuts in Y direction, and remaining 4 cuts suppose we do in Z direction. By this procedure, we can obtain maximum number of identical pieces. So the answer will be 3 plus 1 multiplied by 3 plus 1 multiplied by 4 plus 1, that is equal to 80 pieces can be generated. Problem number 4. What is the minimum number of cuts required to cut a cube into 125 identical pieces? Now in this particular question, they are asking you cuts and they have given you pieces. In previous 3 questions, they have mentioned the number of cuts and they were asking pieces. Okay. So the number of cuts should be minimum and pieces obtained should be 125. So what we will do here, we will factorize the number 125 as a product of 3 numbers which are as close as possible. So 125 can be written as 5 into 5 into 5, as 125 is a perfect cube. Now this 5 can be written as 4 plus 1, here also 4 plus 1, and here also 4 plus 1. So number of cuts in X direction are 4, number of cuts in Y direction required are 4, and number of cuts in Z direction required are also 4. So in 12 cuts, we can obtain 125 identical pieces. So minimum 12 cuts are required. Problem number 5. What is the minimum number of cuts required to cut a cube into 60 identical pieces? For this, again, we should factorize the number 60 as a product of 3 numbers. Now 60 is not a perfect cube. So the 3 numbers in which we are going to factorize it won't be equal. But can we factorize the number 60 as a product of 3 numbers which are as close as possible? Yes, that we can do. So 60 can be written as 5 into 4 into 3. If we factorize it like this, which are as close as possible, we will obtain minimum number of cuts. अगर आप इसको किसी और तरह से फैक्टराइज करोगे तो कट्स मिनिमम नहीं आएगा. फॉर एग्जांपल, इफ यू राइट 60 as 10 into 2 into 3, you won't get minimum number of cuts. So the rule for minimum number of cuts is it should be factorized as close as possible. Okay, now this 5 can be written as 4 plus 1, 4 can be written as 3 plus 1, and this 3 can be written as 2 plus 1. So Cx is 4, Cy is 3, and Cz is 2. So the minimum number of cuts required are 9. Problem number 6. What is the minimum number of cuts required to cut a cube into 200 identical pieces? I request you to pause the video and try this question on the paper. And once you have solved it, you can again resume the video to look for the solution. Okay. How we can factorize the number 200 as a product of 3 numbers which are as close as possible? Well, I can write it as 8 into 5 into 5. This is the closest way of factorizing the number 200. Okay. Now 8 can be written as 7 plus 1. 5 can be written as 4 plus 1, and another 5 can be written as 4 plus 1. So number of cuts made in X direction are 7. Number of cuts made in Y direction are 4. And number of cuts made in Z direction are 4. So the minimum number of cuts required to cut a cube into 200 pieces are 15. Option C is the right answer. Let's move to type 2 question, coloring a cube and then cutting it. So I take a cube here, I paint the external surface of cube with green color and I make 3 cuts parallel to x direction, 3 cuts parallel to y direction, and 3 cuts parallel to z direction. Accordingly, the cube will be divided into 64 pieces. Now, there are 64 pieces generated or 64 smaller cubes generated from the bigger cube. The bigger cube is only painted with external faces and then cuts are made. Now the question is, how many smaller cubes have no face painted? Obviously, the inside core cubes, अंदर के जो cubes है वहां पर कोई paint नहीं लगा है. We need to find out how many such cubes are there. For that, what I will do, I will remove the left layer and right layer. This left layer as well as this right layer. Also, I will remove the top layer as well as bottom layer. As well as I remove the front layer and back layer. So left, right, top, bottom and front, back layers are removed. The inside cubes will be observed which have no paint applied on it, and they are 8 in number. So the matrix of 4 by 4 by 4 get reduced to 2 by 2 by 2. Previous matrix was 4 in length, 4 in depth and 4 in height. As we have removed left, right, front, back, top, bottom layers, the matrix of 4 by 4 by 4 got reduced down to 2 by 2 by 2, जिसमें कोई color नहीं लगा है. Hence, it will be 8 cubes. My second question, how many cubes have exactly one face painted? ऐसे कितने cubes रहेंगे जिसमें सिर्फ एक ही face पे paint लगा है? Smaller cubes. Well, if I pull out any one cube from here, there will be only paint applied on one face. अंदर में तो कोई paint लगा ही नहीं है. So this cube can be considered. Even this can be considered. This and this. We cannot consider any cube on the boundary of the face because यहाँ पर दो surface painted है, and we want exactly one face painted. So these 4 can be considered. So if there are 4 cubes on one face, so there are 6 such faces on the bigger cube. So the answer for this question will be 4 cubes per face multiplied by 6 faces, that is equal to 24 cubes. My next question, how many cubes have exactly 2 faces painted? Obviously, exactly 2 faces painted are observed on any edge. Okay, but on this edge, even if there are 4 cubes, we cannot consider the cube on the corner because corner का कोई भी cube लोगे तो वहां पर 3 surfaces painted है. So if we exclude the corner, in between there are 2 cubes. So 2 cubes on one edge, like this there are 12 edges in this bigger cube. So the answer will be 2 cubes per edge multiplied by 12 edges. The total count will be 24 cubes. My next question. So how many smaller cubes have exactly 3 face painted? They are nothing but 8 corners. So the answer for this particular question will be 8. So we have seen a bigger cube was taken and it was cut into 64 smaller pieces after painting it. So in that, how many are the cubes with no face painted, exactly one face painted, exactly 2 face painted and exactly 3 face painted? Exactly 3 face painted are 8 in number, 2 face painted are 24 in number, 1 face painted was also 24 in number and no face painted was 8 in number. If we add these 4 answers, 8 plus 24 plus 24 plus 8, the count comes out to be 64. Okay. So on this basis, now questions we will see. I will try to explain these questions in best possible manner. There is a cube in which one pair of opposite faces are painted red, the second pair of opposite faces are painted blue, and third pair of opposite faces are painted green. This cube is now cut into 260 smaller but identical cubes. This is the data given, and on this basis 4 questions are asked here and we need to answer this. How we can solve this? First of all, you should make on the paper a cube and represent the faces as the color blue, red and green, and it is clearly mentioned that opposite faces should have same color. So accordingly you can do it. As it is divided into 216 smaller but identical cubes, so obviously it will be a three-dimensional matrix of 6 by 6 by 6, as 216 is a perfect cube. So I will show you how it can be done. Yeah, it can be done like this. Let us say front back is red, top bottom is blue, and left right is green. Well, you can paint it in other orientation also. अगर आपने front और back को green पकड़ा, top and bottom को red लिया, it doesn't matter. Only the care you need to take is that opposite faces should be of same color as mentioned in the question. Okay. Now we will go with one by one question as asked after the given data. The first question: how many smaller cubes are there with no red paint at all? Obviously, the red paint is applied on the front face and the back face. If we remove these two faces or these two layers, there won't be any cube with red paint. So 36 cubes are on the front layer and 36 cubes are there on the back layer. If these two layers are removed, remaining 144 cubes are there with no red paint at all. Second question: how many small cubes are there with at least two different colors on them? At least two different colors means if three color comes, that can be also considered, because the word used here is at least. यानी दो या दो से ज्यादा कलर वाले कितने छोटे क्यूब्स रहेंगे. Okay, two colors are observed only on the edges. So there are 12 edges and on every edge there are 6 cubes. Out of 6 cubes, if we exclude the corner, there are in between 4 cubes. But as the word at least is used, so we can consider the corner also. So what can be the answer of this question? On edges there are 12 multiplied by 4, that are 48 cubes, and 8 corners if we consider, total 56 cube will be there with at least two different colors. The next question: how many small cubes are there with only red and green on their face? Well, you can think about this. You can pause the video, and once you have thought about this, you can play the video to look for the answer. Now we want only red and green. Only red and green can be observed on the edge of intersection of red face and green face. So how many such edges will be there? There will be 4 such edges. 1, 2, 3 and 4, which is hidden to us. So these 4 edges we need to consider, and we want only red and green. So corner cannot be considered, because corner अगर लेंगे तो उसमें blue color भी आ जाएगा, क्योंकि top और bottom में blue color है. So these 4 on every edge which are laterally placed. So the answer for this will be 4 multiplied by 4, that is 16. Option C is the right answer. Fourth question: how many small cubes are there showing only green or only blue on their faces? Now if we talk about the green face here, there are total 36 cubes on this face. 6 multiplied by 6. 6 in height and 6 in length here. Now if we consider any cube on the boundary, उसमें blue या red color आ जाएगा, and we don't want that. We want only green. So we will not consider any cube on the boundary. So in between cubes we will consider. So the matrix of 6 by 6 जो है वो reduce होके 4 by 4 हो जाएगा, because अपन layers छोड़ रहे हैं, left right top bottom. So 4 by 4, that is 16 cubes on this face. So obviously if 16 cubes are on this face, 16 cube will be considered on the opposite face. So green 16 plus 16 32 हो जाएंगे. उसी तरह से blue भी 16 plus 16 32 हो जाएंगे. So 32 plus 32, the answer for this question is option A, 64 cubes, which have only green or only blue on their face. Type 3, non-verbal reasoning question. Now in this non-verbal reasoning on cubes and dice, there are wide variety of questions involved. I will take some sample questions which will give you the idea about the questions that are asked in competitive exam and their solving approach. Example 1. A cube is shown in three views. Which statement is true? That we need to identify. Now, how to solve this? If we look at these figures, first figure and the second figure, we observe the common face in both the figure as 1. तो 1 के अपोजिट में 2 या 3 नहीं रह सकता as they are shown adjacent. Even 1 के अपोजिट में 5 और 4 भी नहीं रह सकते as they are shown adjacent. So 1 के अपोजिट में क्या आएगा? 6 आएगा. If we refer to first figure and third figure now, अगर ये पहला और तीसरा अगर हम देखें, पहले को तीसरे के साथ कंपेयर करें तो 2 इज द कॉमन फेस. सो 2 के अपोजिट में 4 या 6 नहीं रह सकता. इवन 2 के अपोजिट में 1 और 3 नहीं रह सकता. सो 2 के अपोजिट में क्या आएगा? 5 आएगा. सो अगर 1 and 6 आर अपोजिट फेसेस, 2 and 5 आर अपोजिट फेसेस, सो 3 and 4 must be opposite faces. So here we have discovered the set of opposite faces. Now from the given option we need to identify which is true. So we can say that option B is true, that 2 and 5 are opposite faces. Remaining 3 options will be false. Second example, 6 faces of a cube are labeled from A to F and shown in 2 views. Identify the face opposite to C. So from the available 2 views, we can identify the common face at first and it is D. So D के opposite में क्या नहीं आ सकता? A cannot be there on the opposite side of D. F is not there on opposite of D. Even B and E are shown adjacent, so they cannot be opposite. So one face we are left with which will come opposite to D, and that is C. So here it is asked to identify the face opposite to C, which is D. Let's try out example 3. If the following are the two different views of a cube, which face is opposite the face denoted by 2? Now here only 2 views are given. Okay, which is the common face? 3 is the common face. So 3 के adjacent में 1 और 4 दिखा है तो वो opposite नहीं हो सकते, और यहाँ पर 3 के adjacent में 2 और 6 शो किए हैं तो वो opposite नहीं हो सकते. तो 3 के opposite में 2, 6, 1, 4 नहीं हो सकते. So which face can be opposite to 3? It will be 5. Now here we need to solve this question by method of rotation. So this is the primary view of the cube that is shown in the problem statement. I will rotate the cube like this, suppose, so that the face number 3 comes on the top. Face 2 will go on the left side और 6 वहीं पर intact रहेगा like this. And some unknown face will appear here. So 2 is now on the left side, 6 is on the front and 5 is in the bottom. Because 3 के opposite में 5 है, ये हमने पहले ही discover कर लिया. Now suppose if I rotate the cube like this, so that the unknown face will come in the front and now 6 will go in the left, and the face which was on the left, that was number 2, will go on the back side like this. So it will come something like this, so that 1 will come here. Now this figure is very much similar to this figure. Right side में 1 है, ऊपर में 3 है, नीचे में 5 रहेगा, 6 तो लेफ्ट में गया और बैक साइड में 2 चला गया, तो यहां पर obviously 4 आएगा. And from this we can say that the face opposite to number 2 will be number 4, because 2 अभी पीछे चला गया. Like this, by the method of rotation, we can attempt such questions. Now this is another type of question which can be asked in non-verbal reasoning, where a opened cube is shown to you, and by folding its faces, if a cube is formed, then which face is opposite to which face? Like this they ask. As it is asked here, how many dots lie opposite to the face having 3 dots when the given figure is folded to form a cube? So you need to identify the face which is opposite to 3 dot face. So this face. So I will encircle it here like this. तो इसके अपोजिट में क्या आएगा? अगर ये फेस अपन फ्रंट में रखते हैं सारे फेसेस को फोल्ड करने के बाद, so on the top this face will be there, and on the back side this face will go. So the answer for this question is the face with 6 dots. Option D is the correct answer. Example 5. Choose the box that is similar to the box formed from the given sheet of paper. Now a given sheet of paper is here in which 5 faces are represented by A, B, C, D, E and F. If it is folded to form a cube, which is the correct view of the cube that we need to identify. If we check the first option, जहां पर B is shown in the front face. If B is in the front face, obviously E will be on the top face. F can never be on the top face. So this is a wrong view. If we check the second option where E is shown in the front face, if E is in the front face, F can go on the top face, that is okay. And if we imagine that it is folded, D can come on the right face. So I feel this is the correct view. If we check the third view, जहां पर B shown in the front face, if B is shown in the front face, E can be on the top face, but C will be in the bottom face. It can't be in the right face. So this is a wrong view. If we check the fourth view, जहां पर E is shown in the front face, जहां पर left side में A आएगा और ऊपर में F आएगा. यहाँ पर टोटली गलत दिखाया है, ऊपर में D दिखाया और राइट में A दिखाया. So that is a wrong view. So from the given option, option number B is the right answer. Only view number 2 is correct. Example 6. A dice is numbered from 1 to 6 in different ways. If 1 is adjacent to 2, 4 and 6, then which of the following statement is necessarily true? Well, you can make a cube on the paper और उसमें number 1 you can give on the front face और उसके adjacent में आप 2, 4 और 6 represent कर सकते हैं. Suppose I do it like this. 1 I show on the front face and 2, 4, 6 can be shown on the adjacent face. Either the number 6 will be in the bottom or it can be even on the left. Now we need to identify which of the following option will be necessarily true every time. If we exercise the first option where it is said that 2 is opposite to 6, this is not necessarily true. 2 के opposite में 6 भी हो सकता है या 2 के adjacent में भी 6 आ सकता है. If we go with the option B, जहां बोला है 1 is adjacent to 3, even 1 can be adjacent to 3 or even 3 face can go opposite to 1. So this won't be necessarily true. If we exercise the C option, जहां बोला है 3 is adjacent to 5, this can be 100% true because अगर 1 के adjacent में 2, 4 और 6 आ गए तो बचे हुए दो faces 3 and 5 will be adjacent to each other. They can never be opposite to each other. So option C is a right answer. So with this we have explored all the variety of questions which can be asked in your competitive exam, including verbal and non-verbal reasoning. Thank you for watching this video.